While this is a North American event, I'm sure we're all aware that we live in a global economy these days. No matter where you're from or where you conduct business, the dynamics of one market have an impact on another. Even at this conference, we have people from 5 continents, including representatives from China, United Kingdom, Iran, Brazil. In fact, the global connection is especially true when it comes to this industry with its immense scale and diverse applications. So the first thing I'd like to do is really start with a very simple question. What would you say the average person would say if they were asked which has benefited society more, social media or the polyurethanes chemistry? We'll come back to that question in a few minutes, but it begs us to take a look at how industries succeed. There was a time when it was much simpler for companies to get ahead. There were fewer players, and the playing field was less global, less dynamic, and less volatile. The economic drivers still fluctuated, but they fluctuated in a relatively manageable range. So you could invest, invent, and plan with some level of confidence. Now with the outrageous speed of change, the unpredictability and volatility of markets, and this highly connected, expanding global community, the winners will be those who capitalize on this world of change and create a world of opportunity. As an example, who would have thought just 10 years ago that the U.S. Gulf Coast would once again become a low-cost chemical manufacturing region? And when it comes to energy, the lifeblood of this society, who would have imagined just a few years ago that the United States would be exporting gas and would be predicting energy independence by 2020? So back to the question, most of us would agree that the polyurethanes chemistry has helped the world adapt to change and elevated our society to a better place. But the real question is are we extracting as much value as we should? And how do we extract more value for what we're doing? I'm talking about a higher return for our equity, our knowledge, our value chains, and our people. Now I'm going to put my chemical engineering hat on for a second to help understand what that value is. There are 2 main reasons why polyurethane is a super useful molecule. First of all, it's a low viscosity liquid that rapidly converts into a solid material at room temperature. Secondly, there are endless ways to adapt that basic chemistry to work in a wide variety of processes that produce a wide variety of materials. In other words, it has an immense range of properties that span most material needs. So the same chemistry makes things that are super sticky or super hard. It can drip, ooze, expand, solidify, bond, or seal. You can pour it, spray it, bend it, stretch it, and cut it. And it turns out it's one of the best insulators on the planet. That's why it's replaced so many other materials in coolers, garage doors, tool handles, clothing, bike helmets, mattresses, hockey pads, your seat cushion. Polyurethanes is a good alternative to latex condoms. It's been used to replace and mimic human bones. It turns out to be an ideal material for prosthetic legs. So we all work with these amazing materials. But how do we change the game going forward in order to get full compensation for the value we bring? Before I go there, I think it's wise to see what we can learn from our past. So let's take a look at this world of change. We've pulled some data on the per capita consumption of polyurethanes over the last 80-year period. It can tell you a lot. There's not a lot of people looking at this, but it turns out that the polyurethanes chemistry, reacting polyols with diisocyanates, was invented in 1937 by Otto Bayer. Of course, Otto went on to work for Bayer, the company, and continued to advance the chemistry. In this case, Otto's invention was not born of necessity, but he discovered it by chance when he mixed 2 chemical substances together. I'm sure at the time he had no idea how much of a gift his serendipity would become to the world. This science found its first broad application during World War II in mustard gas-resistant clothing, high-gloss airplane finishes, and corrosion-resistant coatings for protecting surfaces. So the first real recognition of its value to society was mostly as an ingredient for protective coatings. At this point, we can see that the consumption was less than a pound per person. Now what I'd like to do is just take a short sidestep to make an analogy to something you might be familiar with. Maslow's hierarchy of needs. The idea here is that you start with the most basic physical need, the things people need to survive, like food, water, and breathing, and then you work your way up to more emotional needs that really extend life and make you happier, like owning property, having friendships, and having self-esteem. And these days, it seems like the higher you go, the more value there is. Well, I think this is a really good analogy for how polyurethanes have been adopted over the years. It appears to be moving from serving the more basic human needs to more complex and even emotional needs. So we start out by providing protection as a broad category of growth. And by the late 1950s, polyurethanes were beginning to show up in a variety of adhesives and elastomers, as well as some rigid and flexible foam applications for household goods. So after protection, we move into what we call the comfort space. Coatings for more aesthetic purposes, carpet backing, and especially flexible foams. All contribute to a more comfortable lifestyle as quality of life moves up rapidly in the developed nations. And it makes sense. When you consider how much sitting and lying we do, to have this foam come in and make those experiences better and healthier. Home construction is reaching a peak in the US around this time, and everybody needs couches and chairs and mattresses. Polyurethane foam has also become the industry standard in car seats, as well as is showing up in more comfortable footwear. You can see the consumption rate is up to nearly 1.5 pounds per person at this time. So in that hierarchy of needs, we're not just supporting the necessities anymore, but moving forward up the happiness curve. As the population grows, more people are moving into the middle class, and what used to be modern conveniences for some become the norm for the masses. So more cars, more convenient foods being shipped all over the world, more hot water for more washing machines, more hot showers, more doggy baths. Only now we're just beginning to figure out that all this consumption comes at a price to our pocketbooks and to our planet. So now we move squarely into the energy efficiency space. Regulations are taking root. We have a cultural shift to more awareness about energy consumption, greenhouse gas emissions, and the impact our consumerism has on the lives we lead. This drives a new wave of innovation in our industry because polyurethane is a superior insulating material. So more pounds are being consumed to insulate buildings, home appliances like refrigerators and water heaters. We're also moving our perishable goods further, so the cold chain explodes, where we're insulating refrigerated trucks and storage buildings. We also see polyurethanes used more extensively in car parts and structural adhesives that make vehicles lighter weight, more fuel efficient, and safer. Think about that for a second. Polyurethanes enabled all this progress, from protection of humans and their property, to comfort and convenience, to energy efficiency that makes a higher quality of life more practical, and keeps our beer fresh and cold on the trip from the Rocky Mountains to our picnic table. And now you can see that the consumption is up to 2 pounds per person. Which brings us to today. You can see in the last 20 years, the consumption rate has nearly doubled to 4 pounds per person. It took us 50 years to go from 0 to 2, and just 20 to get from 2 to 4. That's because the consumption of polyurethanes in these application spaces have continued to expand. We continue to find new and new ways to use polyurethanes. In addition, the global population grew dramatically, more than doubling since 1950 to over 7 billion people in 2010. So if I'm polyurethane, what have I done for society? I just protected your health, gave you a comfortable sleep, insulated your house, kept your water warm, saved you money, made your ride quiet, comfortable, safer, made you healthier and more capable, made all of your stuff last longer, and reduced greenhouse gas emissions. What else do you want? Well, this more sustainable world everyone's after, where economic and social progress are in harmony with the planet's resources, is something our industry and this material is already helping to deliver. We've proven that it's a material that enables higher quality of life more efficiently than most others. So we really simply need to connect the original chemistry Otto discovered in 1937 with the next hierarchy of human needs. But we need to understand what those are. We need to understand where the world's going. Because if you notice, these pie shapes we've been tracking across the chart, we started out with just a few players playing in a very small pie. As the applications grew and the consumption within each application grew, the pie has certainly gotten bigger. But along the way, more and more players around the world have entered the game at different points in the value chain. As a result, the pie has been broken up into smaller and smaller pieces. Now the chain is so fragmented that no one really sees the whole pie any longer. Instead, we all have our little pies, our little pieces. My suggestion here is that we should work on increasing that upward slope of the consumption curve. We should work on making the whole pie bigger so that we all end up with bigger pieces of the pie. And we can make the pie bigger by finding more useful applications that serve this hierarchy of needs. But to do that requires innovation, and it requires collaboration. Keep in mind that the chemistry is not the limiting factor here. It's not about what the polyurethane molecule can or can't do. We know that it can do practically anything. The reality is the limiting factor is us. We can only achieve that innovation by working together in the right ways and on the right things. Of course, being here together is part of doing that. So now what I'd like to do is really go back to the question we had at the beginning. What would the average person say if he asked them which benefited society more, social media or the polyurethanes chemistry? Of course, it depends on how you measure value, but certainly polyurethane has been an incredible gift to the world for addressing basic human needs. But maybe we can learn something from an industry that addresses the very top of the pyramid, up there in the creativity, spontaneity, and problem-solving world. Somehow, for millions of us, they've been able to turn a Wi-Fi connection into a basic human need. Who would have thought 10 years ago that you could reconnect with long-lost friends with just a few clicks of a mouse? Maybe we can learn something about the connected marketplace, about the instant exchange of ideas, about continuous innovation, about business resilience, and about our role in enabling society. We need to be thinking about where we can replace conventional materials in more advanced materials. But we also need to have our fingers on the pulse of what's next in the market. Where are the opportunities for composites? How about the mass customization? For example, 3D printing puts manufacturing in the hands of consumers. What kind of materials does that require? We need to look at minimizing resource consumption, accounting for life cycle of our products, empowering more people to make more sustainable choices. We need to find new higher values uses that address unmet needs. Now, there's a lot of positives we can point to as an industry for being around this long. But it's also easy to get stuck in your ways and lose the ability to imagine your world differently. I'm not saying I have the answers, Dow has the answers, but I'm saying that we as a collective industry have the answers. Together we have a better view of the whole pie. And we need to somehow accelerate down that path of innovation and collaboration. Otto stumbled onto something back in 1937 that brought us all here today. So I look forward to more conversation about my ideas, your ideas, and how we can continue to put this amazing material to work, benefiting our environment, our economies, and our societies all at the same time. Thank you.